So hello everyone. So this is the demo for assignment 3 collab C, where I had to write a collab using PyTorch classes and a 3-layered neural network for non-linear regression using PyTorch's built-in functionality of modules like backpropagation, etc. So this is the notebook. So here I am going to use the NN module, the autograd and the built-in optimizers. So yeah, so again I'll go with the sine wave data plus some noise. So here yeah, this is the equation I'll be using. So I'm randomly generating the data, and this is the data I have created. So for that I'm just using dots, linspace and the other random function. So once the data is generated, I'm creating this regression neural network using inheriting the properties of nn.module of PyTorch. So here I'll initialize it with the input dimensions, hidden dimensions, and the output dimension. So yeah, so this is the first layer where I'll just give the input. It will using the nn dot sequential, it will create a sequential layer of nn dot one linear layer, basically a dense layer, again a dense layer, and then dense layer, and in between it just passing through an activation function of ReLU. So it's as you can see the difference which we did in the earlier. We had to it was very verbose, but using the built-in library, it is very very concise, and it does the job pretty well. Then yeah, so it will basically under the hood create a network of input dimensions, a tensor of input dimension cross hidden dimension, and same over here and same over here. And once that is done, we just have to pass we are calling this the sequential network using our inputs, and it will create the random values and pass it through the network, and give us the value. So this is what the forward will do over here. So we'll just create an instance of our neural network, regression network. Once that is done, this we can use. So in the earlier notebook, I created my own MSE loss function using the formula. So here the PyTorch has this inbuilt function which has the formula inbuilt, and it will, you just have to give it the values y predict and y, and it will give you the loss. So here I'm just creating this criteria, and this optim.adam is the gradient, so type of gradient. So for now we'll just use adam. We can use stochastic gradient as well, but for now I have kept it as adam. I just have to pass the model dot parameters and the learning rate, and we will call it as an optimizer. Once that is done, we will just set our epochs, how many epochs we want, and the losses will be stored in the losses list. Now for each epoch, what I'll do is I'll create the instance which the model instance which we have initiated over here. We will call it train function. It will train the model. After the training it's done, we will get the y predictions using that model. Once we got the y prediction, we will calculate the loss, which is y predict versus the original y. Once that now we got the loss. So now this is the step to clear the old gradients. We're just creating calling optimizer.zeroGrad. It will clear out all the old gradients. Once that is done, we will calculate the um, uh, loss dot backward. So this is where the gradients will be calculated, and the values of the w1 w2, the weights, will be stored. Once that is the gradients are calculated, we will do this optimizer dot step, and this is the step where it will go back and update the weights. once that is done, we will append the losses, take it into in a list so that we can plot it later. And here you can see as the epochs are increasing, the loss is decreasing. So now let's see its plot. So initially the loss was really high, but then eventually as the epochs were increasing, it went down. Now let's see how the our prediction did. So the red one is our prediction, what the model predicted, and the blue one is the data. As you can see, it did quite well in predicting the data. So yes, this is using the neural networks library, sorry, PyTorch's inbuilt library. Thank you.